The previous slide on energy mentioned work, which has the ability to change energy. But what is work? Unfortunately, it's not what we talk about in common language. That happens a lot in physics. There are words that mean something very clear to us when we speak to somebody else who is not a physics person, and we use them in a different way. For example, if you're holding up a very, very heavy box, do you think you're doing work? Using non-physics terms, you may think you're doing work because it hurts to hold the box up for a long time. However, but in physics terms, work is defined as the exertion of a force over a displacement. In other words, the object has to move. To further complicate it, only the component of the force in the direction of the motion is counted. If you're just holding the box, you have a force, you're exerting an upward force on the box, or else gravity would just pull it down to the ground, but the box is not moving, so there is no displacement, hence no work. We have a simple equation for it. Its work is equal to the force in the same direction as the distance, or the displacement. So it's force times the displacement parallel. Let's put some sign conventions on work. If the force acts in the same direction as the object's motion, the same displacement, then the work done is positive. If the force acts opposite to the direction of the object's motion or its displacement, then the work done is negative. And as we talked earlier, if the object does not move, no matter how much force you put on it, then we have zero work. Zero work is done in that case. We'll show this pictorially on the next slide. Here's a picture of what we're talking about. Here's an object here, this little light blue thing, and it's moving in this direction. Why? We don't care at the moment. But we are exerting a force in the upward direction, and yet it is not moving up. Perhaps it's being held down by hooks, perhaps there's some friction there. But in any case, the displacement is here in the x-axis, the force is in the y-axis. So we have no force that is parallel to the displacement, hence the work done is zero. In the second case, we're applying a force to the right. The object has a velocity to the right, its displacement is to the right, so the force is perfectly parallel to the displacement, and the work will be a positive F delta x. The last case, the force is in this direction, the object's moving here. So you might say, how can that be happening? Well, that's the common case if you're driving a car, you hit the brakes. Car does not stop immediately and turn around. It keeps moving, but it does slow down. So we have the force opposite the direction of the displacement delta x, and you can see the negative sign right over here. We have a negative work being done.